Hello guys! Did you miss me? In this video, we will talk about estimation of parameter. Estimation represents ways or a process of learning and determining the population parameter based on the model fitted to the data. Types of estimation. We have two, the point estimation and interval estimation. Number 1, point estimation. Point estimation deals with computing for a single value from a random sample to represent an unknown population measure. The computed single value is called a point estimate. The rule or formula to compute for the point estimate is called a point estimator. A point estimator is said to be the best estimator if it is unbiased and has the smallest variance among all possible estimators. An estimator is unbiased if the mean of its sampling distribution is equal to the true value of the parameter, otherwise it is biased. Second, interval estimation. Interval estimation deals with constructing an interval of possible values from a random sample to estimate an unknown parameter of interest. Oftentimes, the lower and upper limits of this range of values are computed given the general form. Lower limit, upper limit, or lower limit less than parameter of interest less than upper limit, called an interval estimate. The ruler or formula that describes this calculation is called the interval estimator. Now, we will proceed to stat tips.
Stat tips. A point estimator is a rule or formula that gives a single value as an estimate of the unknown parameter called a point estimate. An interval estimator gives a range of possible values called an interval estimate of possible values of the unknown parameter. The sample mean is the best unbiased estimator of the population mean since E sample mean is equals to mean and its variance is variance of sample mean is equals to variance squared all over n. By the central limit theorem, the standard deviation square root variance of sample mean is equals to variance all over square root of n is called the standard error of the sample mean. Hence, for the large sample size n, the sample mean is the most likely a very accurate estimate of population mean. As you can see at the graph, the best point estimator of the population mean is the sample mean. Sample mean is equals to n summation of I as equals 1. X sub I all over n. Population mean as sampling. Sample mean as inference.
10 students have following grades in math: 90, 93, 85, 77, 88, 80, 78, 83, 95, 90. Find the average. To find the average, add them all. The total is 859. Divide by 10, which is 10 students. And the total is 85.9. This is the average. Solve this standard error. The formula is standard deviation all over square root total number of population. The standard deviation is equal to 100 because the grade of total is 100. And the number of population is 10 because of the 10 students. So, 100 is square root of number of population square root. The square root of 100 is 10 and copy. Then solve the 10 all over square root of 10 is equal to 3.16.
Interval estimation of the population mean. Interval estimation of the population mean. In the activity under statistical investigation, how close was your estimate to the true value of the parameter? The distance between the estimate and the true value of the parameter is called the error of estimation. As you can see, mean and sample mean is an error. Confidence interval for the population mean variant is known. In many real-life situations, errors of estimation result since most of the time, the estimates will not exactly equal to the true value of the parameter. The size of the error, this error is absolutely value of difference between the estimate and the true parameter value. You can be 1 minus a times 100% certain that this difference will not exceed e equals to z sub variance over 2 times variance all over square root of n, which referred to as the maximum error of margin of error. Thus, you can construct an interval estimate that contains the true value of the parameter with probability equal to the confidence coefficient 1 minus a times 100%.
Stat tips. Consider the case where the population is normally distributed and the population standard deviation is known. A times 1 minus A times 100% confidence interval for the population mean is given by sample mean minus Z sub A over 2 times variance over square root of n is less than mean less than Z sub A over 2 times variance over the square root of n. The 1 minus A times 100% confidence interval estimator illustrated in figure 1 or case 1 for the population mean is applied when the population is normally distributed and variance is known, whatever the sample size n is. Oftentimes, the population standard deviation and the distribution of the population are unknown. The central limit theorem assures you that as long as the sample size is large, that is, n is greater than or equal to 30, the sample standard deviation and hence the large sample confidence interval estimator can be used. Stat tips. When variance is known or n is greater than or equal to 30, a 1 minus a times 100% confidence interval for the population mean is given by sample mean minus z sub a over 2 times variance over square root of n, or sample mean plus z sub a over 2 times variance over square root of n.
Let's solve the number 2. Our given is sample mean is equals to 78, standard deviation is 20, and our population is 100. Our formula in this problem is standard error is equals to standard deviation over square root of population. Now substitute this formula to the given. Our standard deviation is 20 equals to square root of our population is 100. Now solve for square root of 100, which is 10 and 20 equals to 2. Now for our next question, we have to solve error to get the margin error. Our formula for error is E equals to Z sub A over 2 times standard error of sample mean. And if our A is 0.05, we have to substitute for the formula. Z is equals to A is equals to 0.05 over 2 times our standard error is 2. Now solve for this sub first. Z equals to 0.025 times 2 equals to 0.05.
Example. Suppose that a random sample of 10 students yield the following grades: 90, 93, 85, 77, 88, 80, 78, 83, 95, 90. Construct a 95% confidence interval for the true average. To construct a 95% confidence interval for the true average, you will need formula sample mean minus d sub a over 2 times standard deviation over square root of n less than mean less than sample mean d sub a over 2 times standard deviation over square root of n. Substitute 85.9 minus p sub 0.025 times 66.3 over square root of 10 less than mean less than 85.9 plus T sub 0.25 times 6.3 over square root of 10. Let's perform the operation. 85.9 minus quantity of 2.262 times 1.9 less than mean less than 85.9 plus quantity of 2.262 times 1.99. Next step, 85.9 minus 4.50 less than mean less than 85.9 plus 4.50. Next step, 81.4 less than mean less than 90.4.
Sample size determination for the mean. In many real-life situations, your first task is to decide how large a sample you should get. Determining the sample size will help you obtain a narrow interval with a high level of confidence. This ensures that the error in estimating mean will not exceed the margin of error is equals to c subscript alpha in half multiplied by sigma over the square root of little n at a confidence level 1 minus a multiplied by 100%.
In estimating the population mean by the sample mean, the error will not exceed the margin of error E with a confidence level 1 minus a multiply 100% when the sample size at least equal to.
Since the confidence coefficient 1 minus a multiplied by 100% is established, then z is known. In case the population standard deviation is unknown, you can use prior information on a similar situation, or you can take a preliminary sample and use the sample standard deviation to approximate sigma.
For example, we will be conducting a study to estimate the average daily food expenditure of students. We want to be 95% confident that the sample mean will be within 20 pesos of the true mean. If you can approximate the population standard deviation by 100 pesos and assume an approximate normal distribution, how large a sample should you get? So let's proceed in our solution with example 4.5. Our given is C subscript alpha in hat is equals to 1.96 and our sigma is equals to 100 and error is equals to 20. This is our formula. N is greater than equal to Z subscript alpha in half multiplied by sigma over error squared. And in our solution, we have to substitute our given to our formula. Z subscript alpha in half is 1.96 and sigma is 100 and error is 20. 1.96 multiplied by 5 is equals to 98. 98 squared is equals to 96.04. And for our n is greater than or equals to 97.
Round up to ensure that the degree of confidence will not fall below 1 minus a multiplied by 100% and the sample mean will be within the given maximum error.
Point estimation of the population proportion, the activity under statistical investigation guided you in finding an estimate for population proportion P, which is given by where X is the number of person or object processing a certain characteristics of interest in the population, and N is the population size in real life. The population of proportion is oftentimes unknown and determining it will require a big amount of money or time. Most of the time, the population proportion P is estimated by the sample proportion P given by.
Stat tips. The best point estimator for the population proportion P is equal to X over N is the sample proportion P is equal to X over N. When the sample size N is sufficiently large, that is when P is greater than 5 and NP is multiplied by 1 minus P is greater than 5, where P is the unknown population proportion not expected to be too close to 0 to 1. The sampling distribution of P is approximately normally distributed by the central limit theorem with the mean P is equal to the variance equals to PQ over little n, where Q is equal to 1 minus P. The standard deviation of sampling distribution of P, which is equals to square root of variance multiplied by sample proportion equals to square root of P multiplied by Q all over N, is the standard error of the sample proportion P, denoted by point estimate. If the population proportion P and Q are unknown, you may estimate them by using the sample proportion P and Q, where Q is equals to 1 minus P when the sample size N is sufficiently large.
For example, a survey is conducted to determine the opinions of people on global warming. In a random sample of 150 people and 108 think that global warming is a serious world problem. Number 1. Estimate the proportion of adults who think that global warming is a very serious world problem. Number 2. What is the standard error of this estimate?
In example 4.6, we have two steps. The step 1 is the sample proportion and the step 2 is sample estimate. In step 1, we have the given of little n is equals to 150 and the mean is equals to 108. Our formula is proportion is equals to mean over little n. And to solve our solution, we have to substitute the given to our formula. Proportion is equals to 108 over 150. 100 divided by 150 is equals to 0.72. While in step 2, we have the given of P is equals to 0.72 and Q is equals to 1 minus 0.72 and we will get 0.28. Our formula is proportion equals to the square root of p multiplied by q all over n. To get our solution, we should substitute our given to our formula. Proportion is equals to the square root of 0.72 multiplied by 0.28 over 150. 0.72 multiplied by 0.28 is 0.2016 all over 150. And the square root of this is 0.00134. Then we will get the answer of 0.0367 or 3.67%.
So now, let's proceed to interval estimation for the population proportion. When the sample size n is sufficiently large, you can estimate p by p, multiplying by the denominator of the middle term. The confidence interval for the population proportion p is now given by p multiplied by minus z subscript alpha in half square root of p minus q over little n, less than p minus proportion less than z subscript alpha in half square root of p minus q over little n is equal to 1 minus a, which is equivalent to p multiplied by proportion less than c subscript alpha in half square root of p minus q over little n, less than p to less than proportion plus z subscript alpha in half square root of p minus q over little n is equal to 1 minus a.
Consider large sample with unknown sample size proportion, and sample size q is greater than 5. A 1 minus A multiplied by 100% confidence interval for the population proportion P is given by.
For our half interval width, we have p equals to z subscript alpha square root of p multiplied by q all over n. And for our lower limit, we have p minus z subscript alpha square root of p multiplied by q all over n. And lastly, for our upper limit, we have p plus z subscript alpha square root of p multiplied by q all over n. If an estimate p is equal to the population proportion of p, that is, both of them are located in the middle of the interval, then p estimate p without error. However, most of the time, that is not the case. That is, the error of estimate p minus p is not equal to 0. Using interval estimate, you can be 1 minus a multiplied by 100% confident, that is, the error will not exceed the maximum error or the margin of error e, where e is equals to z subscript alpha square root of p multiplied by q all over n.
So now, let's proceed to sample size determination for the proportion. Determining the sample size at the start of a study ensures that the error in estimating the population proportion P will not exceed the margin of error. Maximum error of E is equal to Z subscript alpha in half square root of PQ over little n. Error with a level of confidence 1 minus E multiplied by 100%. Stat tips. In estimating the population proportion P, using the sample proportion P, the error will not exceed the margin of error with a confidence level 1 minus A multiplied by 100%. When the sample size is at least equal to n, equal to Z subscript alpha in half squared P and Q all over E squared. Stat tips. If there's a no prior or similar given value, P is unknown. You can use n is equal to C subscript alpha in half squared over 4E squared to determine the sample size that will not exceed the maximum error E with at least 1 minus E multiplied by 100% confidence level. This is sometimes referred to as the conservative approach.